Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss how you can create stack data structure using queue data structure. So stack follows LIFO or FILO principle, that is last in first out or first in last out principle, whereas queue follows last in last out or first in first out, that is LILO or FIFO principle. Okay. Now we have to generate LIFO or FILO based data structure, that is stack, using LILO or FIFO, that is queue data structure. Okay. So just let me show you the push and pop operation in case of queue and stack both. Suppose I am having one queue with initially like this kind of element 1, 2 and 10. Okay, so first what happened, first 1 came, okay, 1 is inserted at the beginning, then 2 came, 2 is inserted after 1, then 10 came, 10 is inserted after 2, like that. Appending or insertion happens always at the end in case of stack as well as in case of queue. Okay, like queue you can consider practically like you are in a line to buy a ticket for a particular movie, then the person who is coming after you, immediately after you, he will be standing after you only, right? He will not allow him or her to come before you, right? Same like that, 10 is coming after 2, so 10 has to be placed after 2 only. Okay, 10 cannot be placed before 2. So this is insertion which is happens always at the end of the queue. Okay, suppose one new element 15 comes, so in case of push, what will happen, 15 will be inserted after 10. So our new data structure, new queue structure will be looking like this: 1 2 10 15, 15 corresponding to index position 3. You can consider this as array or list. Okay, if you having index, then that will be 3. Now if I want to implement pop operation, so in case of queue, always removal will be happening from the beginning. Okay, like in if same, consider the same situation, you are in a line. Okay, so line or queue to buy movie ticket, then the person who came first, he or she will be getting the ticket first for the first time, and he or she will be coming out of the queue. So like here 1 came first, so 1 will be removing first. Okay, so our new queue elements will be 2 10 and 15. So this is how pop works in case of queue. Clearly you can observe that this follows nothing but FIFO, that is first in first out principle, because 1 came first, 1 is coming out of the queue also first. Okay, or you can say like this follows LILO principle. Why LILO? Because last in last out, 15 is 15 came last, so 15 will be coming out of the queue at last. Okay, so this is what about queue data structure, that is first in first out or last in last out principle. Now consider the push and pop operation in case of stack. What will happen, I have told you, insertion or inserting a new element in case of stack and queue are same. You have to append that element at the end of your list or array. Okay, like here suppose our stack is 1 2 and 10, so initially 1 was present, then after that 2 came, then after that 10 came. Now when 15 is coming, it will also be appended at the end. So our new structure of stack will be 1 2 10 and 15. Okay, so see 15 is at the end. Now see 15 came last. Okay, now stack says which element came last, that will be removing first. Okay, that is last in first out. So if you apply pop operation, 15 has to be removed first. Okay, so if you apply one time pop operation, I will be getting 1 2 and 10 as element, that is 15 will be coming out of this stack first. Okay, so this is called last in first out, or in the reverse you can say first in last out also, because see 1, this particular element came first, and as we are removing from the end of this stack, so what will happen, 1 will be removing at last. 1 came first, but it will be removing at the last. So this is also called first in last out principle. Okay, so what is the difference, fundamental difference between stack and queue? I hope you've understood. Push operation same, that is always append at the end, but in case of pop, pop operation in queue data structure, the element which is in the beginning part, that will be removed first, but in case of stack, the element which is at the end, that will be removed first. That is the fundamental difference between pop operation. So how we can make stack data structure using queue data structure? See, very simple. Understand it very carefully. This is the main point of the whole story. The element which is coming last, that we are placing at the last in case of stack, and that is removing first. Okay. Now in case of queue, the element always removed which came first, that is which is in the beginning of the listed array. So what we will be doing, we have to do such algorithm, we have to use such algorithm that the newly coming element will be always placed at the beginning of the queue data structure. So as a result, whenever we will be applying pop operation, what will happen, the element which came last, but as it is placed in the first of the queue, so it will be removed first. Okay, and using this we can form queue, that is stack using queue, right? So what we have to do, instead of placing this 15 at the last, we have to place 15 in the beginning, that is before 1. So as a result, as soon as we will be applying pop operation, as in case of queue, pop operation remove the first element, so 15 will be removed first. Okay, now the question comes, using the push and pop operation of queue data structure, how we can insert 15, that is the last coming element at the first. That is the important part. So stack using queue. So only two operations we can do, insert at the end and remove from the first. Okay, this is what we have. Now using this we have to implement stack, because queue follows only these two principles: insert at the end, remove from the first. So suppose we will be now dive into the algorithm which can be implement this particular problem. So what we will do, we will do push operation in a somewhat different way. See how we are doing. Suppose we are having the queue already present as 1 to 10 element. Now 15 we want to push. What we will do, we will create another queue which will be empty initially. Now what we will do, if suppose we want to push some element, first of all I will pop one by one element from our original queue, that is this one, and I will put those popped elements in our empty queue. Okay, so see, the picture will go like this. Suppose I am having one empty queue initially, this q2 is empty, and I am having this particular original queue q1 as 1 to 10. So first I will be popping the first element, because always pop operation in case of queue remove the first element. So one will be popped first. That popped element we will be pushing in q2. So if we apply push operation, one will come here. So our new figure of q1 will be only having element 2 and 10. And now what we will be doing, now we will be removing the 2, that is we will be popping 2, right? Whenever we apply pop operation, remove from the first happens in case of queue. Now these 2 we will push or append in q2 queue. Okay, so what is happening, basically after popping this particular 2, if we push that in q2, 2 will coming here. So our new structure of q1 and q2 will be how, q2 will be having element 1 and 2, and q1 will be having only element 10. Now what we will do, we will remove or pop 10, we will be pushing that in q2. So what will happen, 10 will come at the end, because always appending or pushing operation happens at the end in case of queue and stack both, right? So after all the elements pop, after applying pop for all the elements, when our q1 will be empty, our new figure will be looking like this. q1 is empty and q2 is having the elements 1, 2 and 10. See, we have what we have used, we have just used push pop operation, that is we are removing one by one element from the top, we are pushing that in the another queue q2. Okay, now this 15 we have to insert, right? This 15 element we will be inserting in our q1 which was empty basically. Now if we push that, our q1 will be having only 15 value and q2 will be having 1, 2 and 10. Now what we will do, we will apply pop operation in q2 until q2 become completely empty, and after each pop operation the popped value we will push at q1. Okay, So see, step by step we'll go, no need to confuse anything. So 15 is present and our q2 is having 1, 2 and 10. 1 will be popped first, so 1 will be pushed in q1, so our new figure will be 15, 1, 2, 10. Okay, in case of q1 and q2. Now 2 will be popped from q2 and that will be pushed into q1, and whenever push operation, that means that will be inserted at the end, so our new q1 will be 15, 1 and 2 and q2 having only element 10. Now again we will apply pop operation, so 10 will be removed and we will push that in q1, so our new q1 will be 15, 1, 2, 10. Okay, and again we are getting q2 as empty. Now we will stop. So see what is happening. Basically we have used only two methods. One is add or push the current newly coming element at the end and pop from the beginning, or remove from the beginning, or remove from the first part of the queue. Using that we have created what? We have basically placed our newly coming element at the beginning. Now what we can do, we can, if we apply pop operation, see 15, which is just now we have pushed, which is the last added element as in q1. Now when we will be applying pop operation, the 15 will be removed first, because pop in q always remove the first element, right? So pop will remove the 15. So now this is nothing but last in first out. 15 is coming last, it is removing, we are removing it first. Okay, so see, using only properties of q we can implement stack. Just we have to do push operation wisely. So what is the algorithm? During pushing of a particular new element, we will always having one empty queue. We will first pop all the elements from our original queue and we'll push into our empty queue. Then we will push our newly coming element in our original queue. Then we will pop all the elements from our second queue, which was initially empty, and the popped values we will be pushing in our original queue, q1. Okay, and as a result what will happen, the newly coming element will be always at the top of our original queue, q1. And then if we apply pop operation, as in case of q, pop always remove the first element, so 15 will be removed first. Okay, so this is how we can implement stack using queue, or LIFO or FILO using LILO or FIFO data structure. Okay, I hope this whole story you have understood. The whole algorithm will work in O of n time complexity. Push require O of n time complexity, because what we are doing, basically we are removing one by one element and we are from our original queue and we are pushing that in other queue. So this will take O of n time complexity, and the pop operation will simply remove from the beginning. Again it will take O of 1 time complexity. Okay, so this is what a very popular interview question. I hope the concept is clear to you, how you can implement stack using queue. You can write the code now, as you know the algorithm. The writing code is very simple. In my some upcoming videos I will be showing you the code also. This is all for this video. If you find this video helpful, please like, share and comment, and if you have not subscribed our channel till now, don't forget to subscribe and press the bell icon to get the notification of our latest videos. Thank you for watching.